Alright guys, so today I am going to go over how to find the distance of a line segment. So I'm going to attempt to do it like this, so hopefully it works. Took me a while to set up, but hey, see how we go. Okay, so firstly, we could obviously plot these on a Cartesian plane firstly to figure out the distance of A and B. Okay, so what I mean by that is, hold tight for 2 seconds. Okay, so this is my X, yep, that's my X axis, and this is my Y axis, obviously that's my origin. So 1, 2, 3, 4, 5, 6, 7, 8, and then we've got 1, 2, 3, 4, 5, 6, 7, 8, -1, -2. Okay, perfect. So I just want to, I guess, help you to make that connection that we're making in class today. So firstly, I'm going to plot my first coordinate. So I've got -2, 3. So negative, oh, there we go, -1, -2. So -2 on my x-axis. So -1, -2, and then up 3, 1, 2, 3. Okay, and my next pair is across 6 and up 2. So 1, 2, 3, 4, 5, 6, and then up 2, 1, 2. Okay, so effectively what we want to be able to do is to calculate the distance of this segment. Okay, now how we do that is we use Pythagoras' theorem, okay, which is c squared equals a squared plus b squared. Okay, so like I've got at the bottom, c squared equals a squared plus b squared. Okay, so c is always the hypotenuse, and that's the one that we're trying to identify. So I'm just for the purpose of this, I'm going to label this a and this b. Okay, you don't need to do that. Now here I can see obviously that the distance of this side is 1. This camera's not very good. Oh well. And this side is, well, we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now using our formula, we would go, alright, c squared equals a squared plus b squared. And we know this because we did this back in term 1. So we'll substitute in our values that we know. So it doesn't matter if this is a or if that's a, it doesn't matter. Okay, so 1 to the power of 2 plus 8 to the power of 2. Okay, so 1 times 1 is obviously 1. And then 8 times a is obviously 64. Okay, 1 add 64 is obviously 65. Okay, and then we need to cancel out that square. So in order to do that, we obviously need to find the square root. Okay, because that squaring and the square root, they're inverse operations. So we'll go 65. Now that's totally acceptable answer, and in fact it's more accurate. You could, if you wanted to, get your calculator, okay, and calc. Okay, you could, if you wanted to, no, old skill. My eyeballs aren't working very well right now. Sick. I don't know what I'm doing. Yeah, that doesn't look right. Okay, cool, awesome. Alright, so for the purposes, we are just going to leave it like that, but obviously you could also find a decimal value, and like I always say, to 2 decimal places. So that's effectively what we were doing today. But you don't always have to draw it up, because this isn't always super convenient. Okay, so let's look at, so this is our first, I guess, pair that we plotted, so -2 and 3. So this here is -2, 3, right? And this one here was 6 and 2. Okay, so effectively a quick way, rather than having to draw this up all the time, is we look at firstly our x values, okay, and we can see that this is 6, all right, and this one is -2. So one way that you could, I guess, look at this is you could go 6, now subtract -2 is going to equal 8. Okay, so that's one way of finding the distance of this segment. And then we could go y, so on this second point, 2 take 3, okay, is going to equal -1. Now, even though here we have got a 1, okay, and not a -1, this would still work, because effectively, if we have -1, okay, to the power of 2, -1 times -1 is going to equal 1. I guess that's not the best example, but needless to say, hopefully that still helps. Cool. Don't know how to stop this, so that's good.
Control S.
No, good.